Nathaniel, and welcome to another episode of Debugging Maths. In this video, we'll discuss what a matrix is and how to identify the order of any matrix. So very quickly, let's discuss what a matrix is and how simple it can get. So there's nothing really special about the definition of a matrix. So a matrix in maths is basically the arrangement of information or data. So basically, we take those information that are important to us or make sense to us, and then we arrange them in an array in rows and columns. So basically, we take those information or data, which are called elements in matrix, but don't worry, I will elaborate on that. So it's us basically taking this data or this information and arranging them in rows and columns. It's very simple and very practical. So let me give you an example. What does this mean? So basically, this means that matrix is a systemic arrangement of your data or information. The data or the information are called elements in matrix. Now, all this will make sense to you in a bit. We are taking our data or the data that makes sense to you, or any data that you want to use at all, and then we arrange them systemically in rows and columns. And later on, the data that we gathered in rows and columns we form is some sort of rectangular shape if matrix had a shape. Matrix can be very practical. Oh, and the plural of matrix will be matrices. So don't forget that. So let's assume we have two friends, Tom and Bulu. And now let's assume they both have shoes. Now we're recording their data now, for example. And they have bags too. So now let's assume Tom has 2 shoes and Bulu has 3. And let's assume Tom has 4 bags and Bulu has 2, for example. Now their shoes and their bags are in column, right? Like this is one column and this is another column, like this. So shoes 2 and 3 and bags 4 and 2, right? And Tom's detail is in one row and Bolu's detail is in another row. So you can see how systemic and how cool this is. You get it, right? It's basically an arrangement of data called elements in matrix in rows, like 1 row, 2 row, and column. But don't worry, it makes sense to you. I'm going to bring out this example even more. So in matrix form, it's going to look like this. This rectangular braces 2, 4, 3, 2. You can see it's very simple, and all these things inside here, the numbers, they are called elements. So 2, 3, 4, and 2. You can see a rectangular array or arrangement of data in rows and columns. Very simple. So that's the concept of matrix. Now, what about the order of a matrix? We talked about earlier that matrix is all about presenting and also arranging your data, which are also called elements, in a rectangular form, in rows and columns in rectangular form, right? That's all about matrix. So you can have 2, 3, 4, and 5, and all these things are called elements in rows. This is a row, and this is another row, and the vertical is the column, like we talked about. So what is the order of a matrix? Because this is the most important part. I want you to pay attention to this. This is the order of the matrix. The order of the matrix is so important because if matrices had shape, or like if all these rectangular matrix that you find in your textbook, if they had some kind of shape, they would be called the order. So the order is kind of like the shape, how they look like. It's a way of describing the matrix. Basically, once we describe that matrix by the order, we know by what order the matrix is. So these are some matrices I put up. They're just examples. So, and I forgot to tell you, matrices are always denoted by capital letters, like capital letter A, B, or C as represented. So you can't see a matrix in small letter. That's wrong. You can't see a matrix like that. That is wrong. So how we read the order of a matrix? We read them like this: m by n. So the multiplication sign here means by. So m by n. That's how we read the order. So m here refers to the row and n refers to the column. So basically what we are saying is we start reading the matrix from the row first. We count the number of rows and then we count the number of columns after. Right? It's very simple. So if you want to read this, let's take the A for example now. So how do you read matrix A? What order is this? This would be a 2 by 2 matrix. How? We start with the row first. We have one row. So this is one row and this is another row. So 2 and 1, 3 and 4. So we have one row and we have another row. So we have two rows. So we say by the order m and n, or m by n, we have 2 by 2 because we have only two rows and two columns. The column is the vertical and the row is the horizontal. So don't forget that. So matrix A, you can just write it under here at the base here, and you can say 2 by 2. Very simple. I'm sure you can do this on yourself. It's exactly the same thing. Another 2 by 2. So 2 by 2. So matrix B by the order m by n. Oh, this might vary in your textbook, but this one is common. M by n. And then C. Look at this one now. You can see that matrix is basically the order of the matrix is basically just us interpreting the row and the column. We're trying to we're trying to interpret the shape of the matrix. So anytime you hear order of the matrix, don't be scared that we're just basically trying to interpret the shape of the matrix. C now would be one big matrix. This guy is huge and these guys are smaller. So let's say this is like their grandfather or something, and then these guys are small. So we're just trying to interpret the order. It's very, very simple and you should not be scared of it. So C now, don't forget the order m by n. The row comes first. How many rows is this? 1, 2, and 3. So we have 3 rows. So we come and say C, matrix C has the order 3 by how many column? 1, 2, 3 vertically. 3. So 3 by 3, and you can just write it at the base here. 3 by 3. So let me quickly point out something to you. Let's assume we have a matrix A. So this is how I write the matrix A in caps is equal to, let's assume we have the matrix 3, 2, 2, 3, 1, and 5, for example. So what order is this? The order row by column. So how many row? 2. So 2 by 2. Whenever we have a matrix having the same n and the same n, so the same row and the same column, it is called a square matrix. So anytime we have, so pay attention to this because it's very important. You will find it often in definitions. They will tell you a square matrix, a square matrix, square matrix. So don't be confused. They are referring to matrix, a compact matrix. So the matrix is not too big, not too small. It's just right. The same row and the same column. You can see. That's why it's called a square. Let me give you another example. Let's say B. Let's say a matrix B. Let's say 3, 1, 3, 2, 5, 6, 5, 5, 5, for example. How many rows? 1, 2, 3. So this matrix B has a 3 by 3. So it doesn't matter if it's 2 or 3 or 4, 4 by 4, as long as it has the same M and N and N, the same row and the same column, it is referred to as a square matrix by order, right? Also, another important thing I want you guys to pay attention to in order of a matrix, and you guys should pay attention to this because it is very, very, very important. So you can see that you need to get the order correctly, because if you get the order wrong, then you get every single thing in matrix wrong. So it is very important because they are going to try to test you in the exam on if you know the order, and they will give you other relative order like that. The order of a matrix is kind of like the backbone of matrix. So if you can master the order of the matrix becomes very, very simple. So please pay attention to this because they might try to trick you in addition and multiplication. They might try to trick you if you don't know which order is compact with another order, you get it wrong. So you need to be familiar with this because many people have this problem where they don't know if a matrix can multiply with another matrix. They don't know if it's possible or not because they don't know the order. So that's why, but don't worry, very soon it will become clear. So what order is this now? This is how many row? We have 1, 2, and 3. So we have 3 elements. So these are called the elements 1 and number 2, elements and number 3. So we have 1, 2, 3. We have 3 rows. So by the order m by n, we have 3 rows by how many column? Just 1 column. So this is a 3 by 1 matrix. So this is a 3 by 1 matrix, and meaning m by n is 3. 3 row and n is just 1. And whenever you find a matrix like this having just one column, please pay attention to this. Anytime you find a matrix having just one column, it's called a vector, or more specifically, a column vector. Let me write it here. So whenever you see a matrix with only one n or one column, it is called a column vector. How about this one? This one has only one. What order is this? 1 and 2. So this is a 2 by 1 matrix. You can always write the order at the base of the matrix, like I said before. This here also is going to be a column vector. What order is this? This matrix A will be a 1 by 3. Why? Because it has just one row. Pay attention, it has just one row and 3 columns. So, and this one too has just one row and 2 columns. This one has, don't worry about the length of the column, as long as it has just one row and any number of columns. This is, let's just say 1, 2, 3, 4, 5, this is 5. It is called row vector. A row vector, as you can see. So all these ones here are called row vectors because it has just one row, just one m by any number of n. So whenever you see a matrix like this with just one row, remember the order m by n. So m is the number of rows. So anytime you see a matrix with just one row, it is addressed as a vector, and more specifically, a row vector. Simple. Alright, so that's it for this video, and I'll see you guys in other videos. Make sure you subscribe so when I post those videos you get instant notification on them, and I'll see you guys in the next